In the previous chapter, you have known that the roots of an equation, quadratic equation ax squared plus bx plus c equal to 0, can be found or read from the x-intercepts of the graph of the corresponding parabola. So what does that mean? It means that if you have an equation ax squared plus bx plus c equal to 0, its roots are, let's say, x1 or x2. Suppose it corresponds to a graph which opens upward, and the corresponding graph will be called y is ax squared plus bx plus c. The roots can be found from the x-intercept of the diagram, and then we draw the x-axis, and then suppose it is x1, it is x2. So this is the matching between a quadratic equation and its corresponding quadratic graph. Now we are going to see the significance of the sign of the discriminant in a graph. Let's start from the following. And then so we are still having two columns, in which on the left-hand side, we are talking about quadratic equation, ax squared plus bx plus c, while on the right-hand side, we are talking about the parabola, y is a squared plus bx plus c. To make the presentation easier, I suppose the graph is it opens upward. Well, the first case we're going to study would be delta greater than 0. So if you go back to the concept of delta greater than 0 of a quadratic equation, it means that there are two distinct real roots. So as a result, what does it mean in a diagram? Of course, we are talking about a parabola which cuts the x-axis at 2 points. And so this is the significance of delta greater than 0 in terms of graph. Second case would be, this is case 1. Second case would be when you have delta equal to 0, in quadratic equation, it means one repeated root. And now, if we are talking about its corresponding graph, it means that we have one point of intersection, which means that the graph touches the x-axis at only one point. And so please notice that we use the word called touch to describe the relation between the parabola as well as the x-axis. And finally, we have the third case talking about, number 3, third case talking about delta less than 0. In terms of the quadratic equation, it means that there are no real roots. And then as a result, it corresponds to a parabola which is isolated from the x-axis. Or in words, we would say they do not intersect to each other. After you understand the relation between a quadratic equation and its corresponding quadratic graph, now we have the following conclusion about the values of delta as well as the number of x-intercepts. When you have delta greater than 0, it means there are two x-intercepts of the parabola. Delta equals 0, which means one point of intersection. That means the parabola touches the x-axis. While at last, when you have delta less than 0, that means there is no point of intersection. So it is called 0 over there. So next time when you see a question like example 5, with which you are going to find the number of x-intercepts, then you can simply check for the value of delta, which is b squared minus 4ac. And then now you have to identify the values of a, b, c, for example, in 5a. A is a 2, leading coefficient, 3xe, so b is 3, while c is minus 1. So that's why delta will be b squared, 3 squared minus 4, a is a 2, while c is a minus 1, which gives you, let's see, 17, which is greater than 0. And as a result, you can draw a conclusion that there are totally two x-intercepts over there. The other way to find the number of x-intercepts would be solving its corresponding equation. You can solve the parabola directly, but you can solve its corresponding equation, which is called 2x squared plus 3x minus 1 equals 0. You can simply check your calculator, which gives you x will be 0.281 or minus 1.78. And so you can also say that there are totally two x-intercepts. So now you have two ways to do so. One is using delta, and the other one will be solving its corresponding quadratic equation directly. If it is alright to you, please try part B to part F by yourselves. Next, we are going to see a little bit harder question. Let's have a little challenge here. Now it tells you there's a graph which has two distinct x-intercepts, and then so which means it should be something about delta greater than 0. And next, you know that k is a positive integers. So what does that mean? And I have a question mark over there. But anyway, I now first need to find the range of the values of k, as well as write down the possible values of a. So you particularly pay attention to the word write down. I will be talking about its meaning afterward. Next, in order to apply delta in the quadratic, I need to know ABC very carefully. B is minus x is easy. C is a 3, it's very obvious. But what is A? A should be the number which is in front of x squared or attached to x squared. So that's why your A will be a little bit special or hard because A this time will be k plus 2. And that's why as a result, in order to compute part A, firstly, you talk about delta greater than 0, followed by you have B squared minus 4, A, C, which is greater than 0. So to this, some of you will be finding it hard to simplify the expression, but I give you a little hint here. Firstly, don't expand all the brackets because it may be complicated to some of you. As a result, I would suggest you to deal with some numbers first, which is you have minus 12 first, followed by k plus 2 afterward. Next, you start going to simplify or expand the brackets with minus 12k and also minus 24. And as you go ahead to simplify it, I will do it for you here. Next, you have minus 40. Then be careful that when you are going to divide minus 12 on both sides, the sign will be changed. So that's why you have 10 over 3 finally. And then so this is the mean of range. That means that k is less than 10 over 3, but it doesn't carry a particular value. And afterward, what do you mean by part B? Part B will be ask you to write down the possible values of k. Write down means that you don't need to explain too much, but you just write down the answers directly. Now how to do it would be, so you go back to a question mark I marked for you in the beginning. Because it tells you k is a positive integer, and now k less than 10 over 3. If you check it very carefully, 10 over 3 would be 3 point, okay, so what does that mean? That means k is less than 3.33. So afterward, in order to have k to be a positive integers, k can be, okay, write down the value. Yes, 3 is possible. 2 is also okay. 1 is also okay. But we can't pick 0, minus 1, minus 2, etc. because k must be positive integers. So this is the meaning of write down. So you just write down the value without any explanation. Finally, we come to a very hard question, example 10, in which you are going to show or to prove, show that the equation itself has no real roots for any non-zero values of k. So what does that mean? Now, first of all, a big firm misconception would be many students start from delta has no real roots, start from delta less than 0. It is totally wrong because we are going to ask you to show that it has no real roots, which means you are going to show me why delta less than 0. In this case, the question should be start from look at delta first. Delta would be b squared minus 4ac, so that's why it's b squared minus 4a and then c. So this is your delta. Now you seek for some ways to tell me that why delta less than 0, delta less than 0 in your expression. If you continue to simplify, it's very easy because it's minus 3k squared. Do you remember the feature of k squared or about square in numbers? Yes, that's good. You still have a little bit idea about it. Okay, so now you will see that the question that tells you something special about value of k. It is non-zero. What do you mean by non-zero? K is non-zero, that means it's positive or negative. And as a result, that means k squared should be greater than 0. Because after square, a negative number returns to positive. And then as a result, minus 3k squared should be less than 0, which is our expression we are considering, which means that delta less than 0. And then as a result, we can conclude that now the equation has no real roots. Is it difficult to you? If no, how about I give you another example which is very similar to this one. The question, an additional example or question here will be, can it show that the equation x squared minus ax plus a minus 2 equals 0 has two distinct real roots? So this time I didn't tell you some features about the value of k, but again, you are going to show me that it has two distinct real roots, which means you are going to show me that delta greater than 0, and then why. But the same logic, you can start the question with in this way, which is you start from delta, which is b squared minus 4a, and then c, which gives you a squared minus 4a minus 2, which is called a squared minus 4a plus 8. So it's a little bit hard. A squared, you know that it should be positive, right? Or maybe 0. But minus 4a may be positive, maybe negative, depends on the nature of a. So that's why in this case, we need to make use of vertex form, which help us to find maximum minimum in the question. So which is, okay, so I don't write the step for you, but I just write the results here for you. By using computing square, then we group a squared minus 4a plus 4 together, and there's a residue of 4 over there. While for the brackets, it turns to a minus 2 bracket square, and then plus 4. So what does that mean? Now you can say a minus 2 square, no matter it's positive, negative, or 0, after square, it should be greater than equal to 0. Do you agree with it? I'll repeat again. A minus 2, it may be positive, after square, it's positive. It may be 0, so after square, it's 0. A minus 2 may be negative, after square, it is positive. So in these three cases, you will see that a minus 2 bracket square should be greater than equal to 0. And afterward, if you add 4, so you see it should be greater than equal to 4 as well. But we need not to look at the value for itself, but you definitely know that this is the value of delta, right? And then it's greater than equal to 4, which means that delta must be greater than 0. And as a result, you can say it has two distinct real roots.